Determine whether there is a minimum or a maximum value to each quadratic function. Find the value and the axis of symmetry. Well, for any quadratic function, the thing that you need to pay attention to and make sure you fully understand is that no matter where it's located, the graph of a quadratic is always a parabola. And a parabola is always going to have either a maximum or a minimum value, depending on whether that quadratic is opening upward or if it happens to be opening downward like this green one. Now, regardless, that maximum value is always going to be located at the vertex. So finding the minimum and maximum value of a quadratic ultimately comes down to finding the vertex. Now, because it doesn't specify that we have to find the vertex by converting to standard form first, we are free to use the vertex formula. So the vertex formula looks like negative b over 2a, comma, f of negative b over 2a. Do be careful when using the vertex formula. Most people remember this part, but forget that the vertex occurs at a point and ignore this part. Personally, I prefer simply converting things using complete the square, but students are more formula interested, so I'll help you out this way. So in order to do this, what we will do is first note that the leading term coefficient is positive. And when it's positive, that means our parabola opens upward. And if our parabola is opening upward, we're going to have a minimum value at our vertex. So that's kind of something you need to think about geometrically as you're working through these problems. Okay, so the location of that minimum. Well, the x location of it is going to be negative b, so b is the standard form is ax squared plus bx plus c, or the general form, I should say, the general form of the quadratic. So b is the term multiplying x, so the opposite of negative 6, divided by 2a, so 2 times the value of a. So this would be the opposite of negative 6 is 6, 2 times 3 is 6, so x is at 1, and the location of the height, or of the minimum value in this case, would be f of 1. So we just plug 1 into our equation, and there's a little bit of computation yet to do, but it looks like we would have 3 minus 6 minus 8. So that's negative 3 minus 8, or negative 11. So the vertex itself is at 1 and negative 11. And that is the location of the minimum. Now, the actual minimum value, which is what's being asked here, is the negative 11. So the minimum value is the y value. So that's the value of the minimum. The axis of symmetry. So the axis of symmetry for any parabola is the vertical line that passes through the vertex. These are my axis of symmetry. So to make a vertical line, it's always x equals some value, which is a constant. We just have to know what that constant is. Well, the constant is going to be the x location of your vertex. So the axis of symmetry its equation will be x equals 1 in this case.